So we'll go through some more questions for you guys to get ready for your exams. So we've got some information here. We've got two variables, two sets of information. So it's crying out simultaneous equations. So we want to find out the cost of something. So we're going to have to treat something as an unknown. So hence the reason it's equations. So 3a plus 4p is equal to 184, and 5a plus 2p is equal to 176. Written them as whole numbers, as pence rather than pounds, to make it easier to do the calculations. Although it's a calculator paper, of course, you could have kept it as 1 point something. So if you remember about simultaneous equations, the idea is that we have to change one of the equations if there's not the same number in front of one of the letters already, so that we do have the same coefficient in front of one of the letters. So it looks straightforward to double the bottom equation, so both of these will have 4p in them. So if we double the bottom one, then we get times by 2, we'll get 10a plus 4p. Remember, when you double an equation, you've got to double every term in the equation, so 10a, 4p, and 352. And then we're going to subtract the top equation, so we'll put it underneath so we can see what we're doing. The reason we're subtracting is because the 4p's, take away the 4p's, will become nothing, which allows us just to deal with the cost of the apples. So we've got 10a's, take away 3a's, 7a's, 4p, take away 4p, 4p's are gone. And then we've got 352, take away 184. So 352, take away 184 equals, so 168. And then to find the cost of one apple, we divide by 7, so 168 divided by 7 equals 24 pence. Okay, so an apple costs 24p, and once you know the cost of one of the letters, or the value of one of the letters, then you can put it into one of the equations. Doesn't really matter, so I'll go for this top one. So we've got 3 lots of 24 plus 4p equals 184, so 72 plus 4p, 184, so 4p, take away the 72 from both sides, allows us to get the p's on their own. So 184 take away 72, 112, and then we're going to divide by 4 to get the value of p. So we've got 112 divided by 4, so 28 pence. Okay, once you've got the value of the other letter, we then should check in one of the other equations that we've not used to find the value of the pairs. So we've got the 5a one, so we've got 5 lots of the 24 plus 2 lots of the 28, and we're expecting an answer of 176, so that's 108, that's 56, 5 24s is not 108, 520 is 100, 120. Okay, so 120 plus 56, 176, so yeah, I'll check to work. Okay, so that's the answer to that question. So the cost of one apple is 24 pence, and the cost of one pear is 28p. Alright, so simultaneous equations, then the key idea is you make the coefficients of one of the letters have the same value. Doesn't matter about the operation that's happening before it, it's just having the same number there. And then we can decide whether we add or take away to cancel out the letter we've made that have the same coefficient. Okay, second question then. Alright, so this is asking us to draw a graph of y equals x squared, take away 4x, take away 2. Well, we should realise that this is a quadratic graph, and therefore it's going to have that classic shape. It's take away 2 there, so it is going to cross at take away 2, so it's going to do something like that. So we know it's a U shape, therefore we should expect some symmetry here because the x values are going up in whole numbers, going up in ones, so this should form a symmetry pattern, a symmetrical pattern. So on our calculators then, remember when you put in negative numbers into calculators, it's really important you put them inside a bracket. So we've got -1 squared, take away 4 times bracket, -1, close bracket, take away 2 equals, so 3. And that would make sense because we've got a 3 there as well, so it's kind of looking reasonable. -2, -2. So that would suggest that's going to be -5, but we'll wait till we get there. Okay, so we've got 2 squared, take away 4 times 2, take away 2, which is -6. And then we've got 3 squared, take away 4 times 3, take away 2, so -5. So we've got the symmetrical pattern we was expecting. So now we plot the values, and remember these make up coordinate pairs, so you've got an x number and a y number that go together. So we've got -1 and 3, 0 and -2, 1 and -5, 2 and -6, 3 and -5, 4 and -2, and 5 with 3. Okay, and then we want the smoothest curve we can go through all the points. So ghost it through and put your pen point down when you think you're going to do okay. Remember it's a U shape, so it's really important we end up with the U at the bottom. If this was the 2 points we were given, we'd still have to come down and make sure. Okay, so be careful because I'd lose a mark here because I'm more than 1 square out, so you've got to be careful on how you draw these. Key things about quadratic graphs to remember is that this is known as a turning point, where the gradient of the curve has gone from a positive gradient to a negative gradient. You can have turning points from the top of the curve if it's a negative squared graph, negative quadratic. So watch for that. So that's the turning point coordinate to -6, and the point that the graph crosses the x-axis is when x squared take away 4x take away 2 equals 0, and these are called the roots of the function. So we have 2 roots. The question though says use a graph to estimate the value of x when y is -3. Well, we need to remember that this means that our graph will come down until it reaches -3, so -3 is there. So that is going to be one answer. -3 then symmetrically happens over here, and that's going to be the next answer. Okay, so we can see that our first value is 0.3, so we check the scale of the graph is 0.1 for every little square. And the other value I've got here is 3.7. As long as you're clear and show your method, obviously you should have used a ruler, but I just want to demonstrate quickly. Okay, so drawing quadratic graphs, don't forget you're also expected to know about cubic graphs, so being able to plot cubics which have that kind of elongated S shape, to be able to plot reciprocal graphs that split, so they're the graphs that do things like y equals 4 over x. This is things like y equals x cubed plus 2x plus, I'll take away 1 or something. And then you've got your quadratic graphs that you're expected to know, and then your straight line graphs, your y equals mx plus c. Okay, so just remember they've got all those types of graphs as well that you might be expected to draw. They are about putting values in for x, so use the scale of the graph that they give you, or if they don't give you a graph and they ask you just draw one yourself, then create your own scale. Choose x values to create y values, and that creates your coordinate pairs. Okay, so the solution of quadratic graphs. Okay, so this question is about estate agents and renting flats, and it's about real life graphs. They've given you some formulas and a graph to work out the costs for certain companies, and we've got R, which is worth the monthly rent. This graph is about a conversion graph. Basically, if there's no rent, they're going to charge you 20 quid and so forth just for having the property on their books. So remember, this is called a fixed charge. So you pay the £20, whatever the rent is, and then you pay so much, and we could work out if we wanted to how much you pay per pound of rent, because it'll be the gradient of the graph. So here it's saying that it's £12.50 fixed plus 10 pence, what, 10% of the rental cost. Here they're saying it's 12% of the rental cost, and the gradient here would tell us what percentage of the rental cost it's going to be as well. But we don't need that particular thing because we're going to use the conversion graph as it's been written. So 820 quid a month. Okay, so which estate agent? So there's 3 estate agents to work with, so we should be splitting our answer page in our exam into 3 sections, and we then give them the headings: Saturn, Crown and Rumley's, and then we'd show our workings for each. So for this one it says the cost is the £12.50 plus 0.1 times the rental costs, which is 820. So we've got 12.5 plus 0.1 times 820. So that's going to cost £94.50 for every month. Crown is just 12% of the rental cost, so 0.12 times 820. So £98.40. And Rumley's, we use the conversion graph, and we can see that we've got 10 squares for 200, so each square is worth 20. So that's our £820. So we'd get our ruler. So we'd get our ruler, and we would come up to the graph, and we can see that it fits an exact value here of £100. So we would come across, show the examiner our method. Quite often when you're reading graphs it's useful to go across the axis so you can actually read off more carefully what's going on. And for Romney's it's £100. Okay, so we've used the formulas that they gave us for working out the costs for each company and the conversion graph for Romney's. And the question says which estate agent, and we would choose Saturn based on the fact that it's cheaper per month. So Saturn. So basically choose Saturn, costs less per month. Okay, so that's how that question could be answered. Here we've got another real life graph question. It's about hiring chainsaws, and this graph shows the cost of hiring for 12 days. So basically they're saying there's a fixed cost of £10, and then it's so much per day, which would be the gradient of the graph if we wanted to work it out. So it says find the cost of hiring a chainsaw for 6 days. So we can see that 6 days was there. So we would come up to the graph, come across, and then read off the answer. When we work out the scale of the graph, we can see there's £5 for 10 squares, so each square is worth 50p. So it's 15.50, 16, 16.50, 17, 17.50. Okay. The cost of hiring a chainsaw from Saws R Us is £10 plus daily rate. Work out the daily rate. Okay, well the daily rate is going to be the gradient of the graph because it's so much per day. So we've already got a value there. So if we create our triangle for our gradient, then we can see the change in y, because the gradient, remember, equals the change in y divided by the change in x. So the change in the vertical axis divided by the change in the horizontal axis. Some people remember it as rise over run. So the change from £10 to £17.50 is £7.50, and I've gone across 6 days. So the daily rate for my triangle will be £7.50 divided by 6. So £7.50 divided by 6. So £1.25 per day. Okay, so basically to work out this question, then the cost of hiring the chainsaw is £10 plus the daily rate. Work out the daily rate. The daily rate is the gradient of the graph because it's cost per day. So I've just drawn a little triangle connecting 2 points. Worked out the change in the y divided by the change in the x. And it doesn't matter where I did that, then because it's a straight line, the gradient will be the same. So that would be the answer there, £1.25 per day. The question goes on, and it talks about someone wants to compare the cost of hiring and source due. Source due charged £3 for each day of hire. Simon has changed over a different period of time. She wants to use the cheaper company. Which of these two companies do you must show you working? Okay, so it's £3 for each day of hire. There's no fixed charge. Okay, so for 2 days then it'll cost £6. For 0 days it'll cost £0. And for 12 days it would cost £36. We don't have 36 on the scale, so I can't use that. For 10 days it'll cost £30. Okay, so basically what we're going to do to compare them is we're going to draw the conversion graph to work out the cost of hiring from source to you, and if we connect those points together, label the graph to show that this is for source to you. Then we can see on the graph that there's a point where it's cheaper to hire the chainsaw from source or us than source to you. So up to this point here, which is between 5 and 6 days, source to you is cheaper, and then after for 6 days onwards it's cheaper to hire the other one. So basically what they're expecting you to do here then is say something like, from the graph I can see up to 5 days of hire cheaper to use source to you, but if you want 6 days or more, then it is cheaper to rent from, or hire, is it? It's about hire, rent, for hire from source ours. Okay, so that's how that question could be answered, by drawing the graph for the other one and then seeing that the crossover points here. So up to 5 days, then it's cheaper for this company, and after 6 days or more, it's cheaper for this company because the cost is lower. Okay, so an example of real life graphs. Remember, fixed costs start there with 0, and there was no fixed cost for this company, just a straightforward £3 for every day. Okay, so this next question talks about a distance, time. Yep, so it's got times and distance, and it's talking about speed. So as soon as we see that word, then we should be writing the connection between speed. So speed is distance divided by time, and for a lot of you, 3 variable formula, so have the triangle as well. Okay, so the question goes on and asks us to work out the average speed from Ganby to Horton. Well, that means we could do with knowing the, because we've got speed, we need the distance. Well, we've got the distance is 18 miles, but we need the time. And when we look at the answer line, we can see that they want the answer in miles per hour, so we've got to be careful about that. So we'd need to know the time, so let's draw a timeline. So set off at 10 o'clock, and she drives 40 miles an hour. Wants to get to Horton at 10:35. Okay. So we need to know this time here. Alright, so from fullback to Ganby, then because we need a time, then we cover time up, distance divided by speed. So time is distance divided by speed, and the distance they're telling us is 10 miles, and the speed between Fullback and Ganby on average was 40, so that's a quarter of an hour. So 15 minutes. Okay, so we know now at Ganby we got there at 10:15. So Ganby to Horton. The question wanted the speed. Well, that's the distance divided by the time. Time is 20 minutes, but the question wants the answer in hours, so 20 minutes, we need to remember, is 1/3 of an hour. This is a calculator paper, so we can divide by 1/3, not a problem. The distance was 18 miles, and we're dividing by 1/3 of an hour. Okay, so when you divide by 1/3, it's the same as times in by 3, so 54 miles per hour. Okay, so that was the answer to that question then. So speed, remember the formula, distance over time, triangle to help you decide which way around you need to do things when you've got two pieces of information, and just basically working through some logic of this question to get the answer. So 54 miles per hour. Okay, so here we've got another journey question, and we've got to draw a travel graph. Okay, so distance time graph. Scale, so work out the scale. So we've got 10 squares for 5 kilometres, so for this scale every square is half a kilometre, and on this scale we've got 10 squares for every 30 minutes, so 1 square is equal to 3 minutes. Okay, so it's important with graph questions that you work out the scale that you're working with, just in case you've got to plot things. Okay, so what does it say then? At 9 AM begins this journey, and from 9 AM to 9:36 he travelled at 15 kilometres per hour. So 9:36. So 9:36 is there, 2 squares, because 3 minutes for every square. So we're going to need a distance. Okay, so speed equals distance over time. So distance equals speed times time, and he's travelling at 15 kilometres per hour, and the time was 36 minutes, but we recognise that 36 minutes, it needs to be in hours, so 36 over 60, because 60 minutes in an hour. So we're doing 15 times 36 over 60 equals, so 9 kilometres. So we travelled 9 kilometres. So 9 kilometres, 36, put across. Now a constant speed is always a straight line, so that's the first part of the journey drawn. And then it's saying from 9:36 to 10:45 further 8 kilometres. So we need 10:45, so that's going to be there. And if you travel another 8 kilometres, that's 9 plus 8 is 17. So 17 kilometres, 16, 17. Okay. There was no stopping on this journey, so there's no horizontal lines at this stage. From 10:35 to 11. Okay, so that's the distance time graph, drawn the travel graph. And then the question goes on, and it talks about a 15-minute, so a quarter of an hour here, and average speed of 18 kilometres, work out the distance. Okay, so we know that distance is equal to speed times time. It's travelling at 18 kilometres per hour, and we're timesing by a quarter of an hour, which means the hour units all cancel to 1. Therefore we're left with kilometres, so we need a quarter of 18. So a quarter of 18, 18 divided by 4, so 4.5 kilometres. Okay, so distance speed graph, constant speed, then straight line. If there was a stopping part in the journey, then it would have been a horizontal line, and so forth. Okay, so practice distance time graphs and speed. Okay, so this next question goes on and talks about stem and leaf diagram, and it's telling us it's about the speeds of cars, and we can interpret the stem and leaf diagram as this number here, for example, is 43 miles per hour. How many of the cars had a speed of more than 50? Well, 50 would have been a 0 there. So more than 50, there was 1, 2, 3, 4, 5, 6. So 6 cars had more than 50. Find the median speed. Well, there's 25 cars, so the middle car will be the 13th, because there's 12 before it and 12 after it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 before the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 after the middle. Okay, we interpret that as 44. The range of speeds, well, the range is highest take away lowest. The highest speed was 60 and the lowest speed was 29, and when we do that subtraction we get 31 miles per hour. Okay, so stem and leaf diagrams, remember they have to be in numerical order and you have to put a key, and finding the median and the range is quite often asked for, so do practice those. Okay, so this question talks about buses leaving every 24 minutes and every 20 minutes. So we're starting at 9 o'clock. When will a bus leave? Right, okay. So this is a lowest common multiple question where we want the lowest common multiple of 20 and 24. So we've got lots of ways of doing lowest common multiples. We could write out the 24 times table as the largest number. 48, 72, 96, 120. So we can see that this is also a multiple of 20, so that will be the lowest common multiple. Now as this is in minutes, that's 2 hours. So both buses left at 9 o'clock. So the next time they're going to leave together is 2 hours later, so that would be 11 o'clock. Okay, the other way of doing this question, if you're not happy in doing lowest common multiples, is to write out the bus times and see when they coincide. So both of them set off at 9 o'clock, and this was every 24 minutes, and this was every 20 minutes. And it was every 20 minutes, 9:40, 10 o'clock, 10:20, 10:40, 11 o'clock. So again, we could do it by writing out the bus times, and we could see that 11 o'clock will be the next time they both coincide. So lowest common multiple problem. The next question goes on and talks about expanding. Well, we recognise that means multiply what's outside the bracket by what's inside. So we've got 3 lots of 2y, which is 6y. And then we've got 3 lots of 5, which is 15. There's a minus sign, so we're taking away the 15. Factorise, both of these terms have a common factor, so therefore it's going to be a single bracket where the outside of the bracket is going to be the highest common factor. So we look at these two terms and we can see that 8 and 4 both have a highest common factor of 4, and we can see that x squared and x have a highest common factor of x. So don't forget factors go into other things and leave no remainders. So we then divide both of these by 4x. 4 times 2 will make 8, and x times x will make x squared. 4 times 1 makes that. X is already there. We've got a y short, and there's a plus in the middle. Okay, so then we can check it. 4 times 2 is 8, x times x is x squared. 4 times 1 is 4, x times y is xy. Okay, so that will be that one. Remember, with these it's really important, highest common factor outside the bracket. Make h the subject of the formula, so it's already giving you a clue that it wants it at h equals. H is already positive, so we're going to leave that, and then we're going to move the other two parts of this expression. So this says divide by 10, so we move that by timesing, so that's going to give us 10t is equal to gh. This says they're timesing because they're next to each other with no operation between them. So to move the g, because it's h that we'll leave on its own, we're going to divide by g. So we have 10t over g. So h is equal to 10t over g. So again, practice rearranging, and it's this idea of moving things from one side of the equals to the other by doing the opposite operations. Okay, so we've got a question here involving fractions and decimals and percentages. So, right, okay, so 250 DVDs. So 42% of something is the same as doing 0.42 times. So we're going to do 0.42 times 250. So there's 105 thrillers. 2/5 are comedies. So again, we're going to do 2/5 of something. Calculated paper nowadays. So 2/5 can put it as a fraction times 250. So 100. So we're doing 2/5 times 250. So there's 100 comedies. The rest of the DVDs are science fiction. So basically we have to do 250, subtract 105, subtract 100. So 250, subtract 105, subtract 100 equals, so 45. Okay, so just remember doing percentages of things on calculated paper now is fairly straightforward. Always turn your percentage into a decimal, call the percentage multiplier, and then multiply through. 2/5, when you want to do any fraction of anything, and you just do the fraction on the calculator times whatever they want you to do the fraction of. Okay. Alright, so this next question is talking about a conservatory with a particular floor plan, and it's going to cover, and they're telling you that a pack of tiles will cover 2 square meters. So as soon as you see those square meters there, then the question's shouting out to do area. So basically we have to calculate the area of this shape. We don't have a formula for that kind of shape, but we can see fairly quickly that we can split this shape up into 2 bits, where one of them is a rectangle of length of 3, height of 2.2, and the other shape is a trapezium, which got a length of 1, a length of 3, but we also need the vertical height of this, and we can see that the whole of that was 3.4, this bit was 2.2, so if we do 3.4 take away 2.2, then we get 1.2, so this has a height of 1.2. So the area of a rectangle, 3 times 2.2, so 6.6 square meters, and the area of the trapezium, well, we know that's a half the sum of the parallel sides times the height between them. So we get half times 1 plus 3 times 1.2. Okay, so 1 plus 3 is 4, half of that is 2, so 2.4 square meters. So the total area is 6.6 plus 2.4, so 9 square meters. Okay, so that's used. So 1 pack of tiles will cover 2 square meters, so we need the number of packs. So the number of packs will be 9 divided by 2, so 4.5. Can't buy half a pack, so we need to buy 5 packs. So watch for that, because real life you can't go and buy half a pack of things or half a tin. So we need to recognise that if we do need 4.5, then we need to round up to actually buy the number of packs we need. So the cost of the packs. Now here we've got to be careful, because she gets a discount of 25%. So the cost of the packs is going to be 5 times £24.80, but then we're going to times by 0.75. That's your 100%. Take away your 25% discount. So left with 75% to pay. Okay, so we need to be careful when we're doing discount kind of questions that we take that into account. If we've got 25% off, then we're left with 75% to pay, which is the same as timesing by 0.75. So we've got 5 times £24.80 times 0.75 equals, so £93. So the question says Mary has £100. Does Mary have enough money? So yes, Mary has enough money with £7 left. Okay, so that's how that question could be answered. Excuse me. Okay, so this question talks about a prism. So as soon as we start seeing a prism, then we usually start thinking of volume, unless it's asking us to name the things. So the volume of a prism, we must remember, is the area of cross-section. So the shape that makes the prism times the length. Okay, so for this one we're told that the cross-section is a trapezium. So basically we need to work out the area of the trapezium. So we've got the area of the trapezium is equal to a half the sum of the parallel sides times the height between them. So in this case it's going to be 3 and 1.4 because they're the parallel sides. So we've got 3 plus 1.4 and we're told the height between them is 2.4. So 0.5 for a half times bracket 3 plus 1.4 close bracket times 2.4 equals, okay, so 5.28 cubic meters, because we're talking about meters and it's a volume. Oh, that's area actually, sorry, that's a trapezium, isn't it? So 5.2 squared. So the volume is going to be 5.28 times the length between the two cross sections. So there was the cross section and 2.5 is the length between. So we're going to times by 2.5 equals, so 13.2 cubic meters. So volume of the tank. Okay, so you can only fill it to 85%. So oil capacity is 0.85 times 13.2. So times 0.85. So 11.22. Now they've given us this conversion because they're telling us that there's 300 litres already in the tank. So if we do 300 divided by 1,000, then 0.3 cubic metres in the tank. So we subtract 0.3. So subtract 0.3, so 10.92. Okay, so we've got to put 10.92 metres cubed in. It said it's after 1 minute and it's going to flow at the same rate. So basically we've got to do 10.92 divided by 0.3. So divided by 0.3 equals, so 36.4 minutes. Okay, so that's how that question could be answered. The question then goes on and says the assumption this could be wrong. Explain how this would affect your answer to part A. If flow rate reduces, time will be longer, time to fill will be longer, and vice versa. Okay, so if the flow rate reduces, time to fill will be longer. Logical. Okay, so that's how that question could be answered. This question talks about proportionality, and so it's inversely proportional. So basically what they're saying is that the temperature, okay, so temperature and depth. So basically they're saying as the depth increases, the temperature will decrease. Okay, so this is the equation that maps that. So it says work out the difference in temperature of the water at a depth of 1200 and 2500. Okay, so we're going to have to do T equals 4500 divided by 1200 first, because X is the depth. So 4500 divided by 1200. So 3.75. and then we're going to have to do 2,500, so 4,500 divided by 2,500, and 4,500 divided by 2,500, so 1.8. And the question says work out the difference in the temperatures, so we're going to have to do a subtraction, so 1.95. So 3.75 take away 1.8 equals, no, I did the take away the other way around, ended up with a negative, but I could ignore the negative because I knew I was doing it the other way around, and the difference actually is 1.95. Okay, so one of the graphs could show that t is inversely proportional to x. Write down the letter of this graph. Well, in the introduction, reminded us what inverse proportion means, as one variable increases, the other decreases. So the only graph that's doing that curve, where one increases, the other decreases, is graph D. Okay, this would be direct proportion, so y would equal kx. This would be no proportion, and this would be direct proportion. Goes through 0, goes through 0, that's what direct proportion graphs do, but this would be a quadratic parabola. So y equals some proportionality constant times x squared, or t squared in this case. Shouldn't necessarily say x, because it's about, oh, it is about x actually, but it should be t equals not y. Okie dokie, so that's proportionality. Look it up and practice it. Okay, so this question talks about making t the subject. Now t is there, already positive, so we can leave it alone and move everything else. So this has a 3 involved with this term and the letter, the subject letter, and this term is totally separate. So we do the separate terms first. So we move things from right across the equals by doing the opposite operations. So to make this become 0, I add 2a. So we get y plus 2a is equal to t over 3. And because I want to leave t on its own because it wants t as a subject, then this says divide, so the 3 comes across by timesing by 3. So the answer here then is going to be t equals 3 brackets y plus 2a. Put in the bracket because we're multiplying all of this by 3. So y plus 2a and the 3. The next question talks about rounding to one decimal place. So in other words, there's been a scale of some kind where 7.2 was on it. Before that would have been 7.1 and 7.3 as we're measuring to one decimal place. And it wants the error interval. So error intervals are what's called the accuracy of measurement, and the accuracy is always a half of the the error is always a half of the accuracy given. So we go halfway between, we get 7.15, go halfway between, we get 7.25, and this is known as the lower bound, this is known as the upper bound, and the boundaries are what they are. They're just boundaries to say that the measurement could have actually been as low as 7.15 before it got rounded to 7.1, and it could have been as high as 7.25. Although 7.25 would round up to 7.3, it's a boundary, and the way we show that on the error interval is to remember that error intervals have these two symbols, where the top one is always less than. We can't actually include it, but it's a boundary, but we write 7.25, and it's about a number x, so x would be in the middle, and the lowest bound is 7.15. So error intervals, you need these two symbols, where that's the less than, greater than or equal to, upper bound on the right hand side, lower bound on the left hand side, and sketching these scales, putting the number on that they told you, and then what was the number before it, what was the number after it, go halfway, gives you your boundaries. Okay, so this question talks about a Venn diagram, and we need to remember that the whole of this circle is talking about the set A. So set A has 3 numbers in it, and so on. We need to remember that these symbols have some special meaning. These symbols, this one means the union, and the union is where you include everything within the circles. Now don't forget there could be more than 2 circles, could be 3 and so forth. So the union is all the numbers that are enclosed in the circles. So here we've got 15 just coming from left to right, so 12, 18, 10, 14 and 16. This one talks about the intersection. The intersection is where the two circles or three circles cross each other, and in this case there are only two numbers in the intersection, so 12 and 18. It says one of the numbers is chosen at random. Find the probability. So probability we tend to think of in these kind of questions as a fraction, where the bottom's the total and the top is what you want. And it says the set A dash, and we need to remember that this means not in A. The dash is saying not in. So all of these are in A. We want the ones that are not in A. So 1, 2, 3, 4, 5, 6, 7. So there were 7 numbers not in A, and there were 10 numbers altogether. So the answer here would be 7/10. Okay, so estimated mean average. We need to remember that when it says estimate the mean, then we've got groups here. We don't know the exact waste measurements, but we do know that the mean is defined as the total of all waste measurements, or waste sizes should we say, divided by the number of customers. And we're going to estimate this by adding on an extra column here, and because we don't know the exact measurements for each of these 24 people and so forth, we're going to use the midpoint. We're going to use the middle of the interval to estimate it. So we do the midpoint times the frequency when we do estimated mean. So we got the middle of 28 and 32, it's 30 times 24, 34 times 12, 38 times 8, and 42 times 6. Okay, 34 times 12, 340 plus another 68. I'm just going to make 408. We will do it on calculator because calculator paper. So 34 times 12, 408. Okay, so 38 times 8, 224. And 42 times 6, 252. Because we want the totals, then we always add on 2 boxes at the bottom of this table. The total frequency, well, we know it's 50 because they told us there was 50 customers. And we need to work out the total waste sizes, so 720 plus 408 plus 224 plus 252 equals, so 1604. And then we're going to divide that by 50. So 32.08. Now what we need to remember is to check, and when we look at this, 32.08 is within this group, and it's within the range of numbers possible, so we've got confidence that we might be okay with the answer. And it would seem reasonable because there's 24, so nearly half the people have got a waste size of less than 32 or equal to 32. So 32.08 would be reasonable. Okay, so belts are made in sizes. Jenny needs to order more belts in June. The modal size of the belts is small. Jenny is going to order 3/4 in size small. The manager of the shop tells Jenny she should not order so many small belts. Who is correct? Okay. When we look at the table, we can see that just under half the belts were small, so 3/4 would be too much. Although the modal size is small, it happened the most, it's still less than half the belts. So the manager is correct. So the manager is correct as just about half the belts sold were small, not 3/4. Okay, so anything like that would give you the marks, because you're understanding that although the mode is small, only about half the belts are small. Okay, so this question asks you to compare some investment plans, and so it's a calculator paper, so we can use right, so it's 2 years. Okay, so it's about 2 companies, so split our answer into 2 parts, so Sterling and Jupiter, and it says 3% for the first year, and we're investing £8,000. Okay, so for Sterling then, in the first year, it's going to be 8,000 times 1.03. Now remember, the 1.03 comes from 3%, so that's 100% plus 3%. So 103%, which is equivalent to 1.03 as a decimal multiplier. Okay, so at the end of the first year then, we have the 100% originally plus the extra 3, so we times by 1.03, £8,240, and then at the second year we have the 8,240 from the first year investment, but this time we're ties in by 1.022, 2.2% extra, 102.2, turning into a decimal 1.022, so times 1.022, so £8,421.28, 2 decimal places for money. Right, and Jupiter says it gets 2.5% for each year. So the first year, 8,000 times 1.025, and in the second year we're going to get 8,000 times 1.025, because that's the value of the first year, times another 1.25 for the increase for the second year. So that's the same as doing 8,000 times 1.025 squared. 2 years, so 8,405. Which is the better investment? Well, Sterling gives you more money, so basically we're going to conclude that Sterling is the better investment, gives more money in interest. Okay, so that's how that question could have been answered. Okay, so this question goes on, talks about 150 children, and it says there were twice as many children who used a computer between 8 and 10 hours as compared to the number of users for 2 to 4, because we're going to fill in the missing numbers. Okay, so what we got so far, so we've got 150, take away 15 plus 35 plus 45 plus 10. So 150 take away bracket 15 plus 35 plus 45 plus 10 close bracket equals, so 45. And it says there were twice as many children, so okay, so that's a ratio of 2 to 1. So we've got 3 parts. So we do 45 divided by 3, which is 15 per part. So twice as many, so we're going to times this by 15, so 30 to 15. So 8 to 10 hours was 30, and the other one was 15. Stephen says, I think 36% of children use their computer for more than 8 hours. So when we look at the table, it's about percentages, so we should think fraction times 100. Could I turn a number into a percent? So this kind of process always gives you a percent. And we want the total on the bottom, so there's 150 children, and it says 36% of children more than 8 hours. So we can see more than 8 hours is these two. And that's 40. So we're going to work that out. 40 divided by 150 equals times 100 equals. So 26.6 recurrent, 26.7%, 3 decimal places. So I think 36% of the children more than 8 hours is Stephen correct. Stephen is incorrect, as only 26.7% use their computer for more than 8 hours. Okay, so that's how that question could have been answered. Alright guys, good luck in your revision. Make sure you're doing plenty of it.